Okay, Foundations Pre-Cal 10. Here is a short for arithmetic sequence. It's going to cover the same questions in the full video, but this one just breaks them down a bit quicker. I don't go in as much detail. So the first example is find the 12th term of the arithmetic sequence 2, 5, 8, da 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 da. First thing we can notice, the common difference is 3. Next thing we can notice, my first term, my A or my T1 is 2. So if I want to find the 12th term, it means my n is 12. So it means my 12th term, T12, is equal to A plus 12 minus 1 times 3, which means T12 is equal to 2 plus 11 times 3, which means my 12th term is equal to 2 plus 33. So the 12th term in that list is 35. So what about if we have the last term? We have the first term, so A is equal to 4. We can see the difference is 3. And we know this is our Tn. It is our nth term. We just don't know what n is. So we can still say, well, my Tn is 439. And what I'm trying to solve for is n. So my n stays empty in this case, blank. So now, algebra, subtract 4 from both sides. You get 435 is equal to 3 times n minus 1. I just rearranged the order of those numbers. Becomes a little bit more familiar. Then we will subtract both sides by 3, and we get 145 is equal to n minus 1. And then if you add 1 to both sides, n equals 146. So it means that 439 is my 146th term, which means T146 is that number. We have solved for the n in my Tn. So what if we're given some info like this? The 7th term, T7, is 78, and the 18th term, T18, is 45. Well, consider the difference between the terms and the term numbers and the difference between the terms themselves. So that means that T18 minus T7 is 11 terms. And it means that 45 minus 78 is negative 33. So it means between 11 terms, there's a total difference of 33, which means that 11 times d is equal to negative 33. And if we divide both sides by 11, d equals negative 3. So we've solved for our difference. Once you have that information, you can use either of the two pieces of information given to us and plug it into the equation now to solve for A, because I'm going to use T7, right? T7 was 78. So that means 78 for T7 is equal to A plus, now n is 7 this time, because I'm using T7. And now I know my D is negative 3. So I've started to fill in those puzzle pieces, and it's all becoming more clear now because I have information that was missing. I just get down to computation and a bit of arithmetic. So now add 18 to both sides, and we say A is 96. So that's sort of the most complex in the arithmetic sequence until we give you a sequence that has variables in it. Now in this case, the goal is to figure out what x is so that 3x plus 2 is a term, followed by 2x minus 3 as a term, followed by 2 minus 4x as a term. So you put brackets around them to sort of track that they are terms themselves. And let's start by figuring out the difference. And if you think about term 2 minus term 1 versus term 3 minus term 2, we could say that, okay, well, 2 minus 4x as term 3 minus 2x minus 3 as term 2 should give us a common or a difference. At the same time, we can identify the fact that term 2 minus term 1 should also give us the difference. Now in the full video, I've solved those out and then set them equal to each other. In this one, we'll do it all at once. You can see that since both of these statements are equal to the same thing, we can write them equal to each other. It's kind of like, it's not kind of like, it's exactly like the fact that 1 plus 5 equals 6 and 2 plus 4 equals 6. So it only makes logical sense to say that 1 plus 5 is equal to 2 plus 4. That's what we're going to do here. And we're going to say, okay, well, 2 minus 4x minus 2x minus 3 is equal to 2x minus 3 minus 3x plus 2. And this looks kind of nasty, but this is basically an algebra question from grade 9. So we are going to remember to subtract those, water bomb, and subtract those. And our equation becomes 2 minus 4x minus 2x plus 3, be careful there, equals 2x minus 3 minus 3x minus 2. We're going to group like terms together. So on this side, we get negative 6x plus 5. And on this side, we get negative x minus 5. The last step is to get our x's on one side and non-x's on the other. So I'm going to add x to this side and add x to this side, which gives me negative 5x plus 5 equals negative 5. And then I'm going to subtract 5 from both sides. And that gives me negative 5x equals negative 10. My last step is to divide both sides by negative 5. And we have solved for x. X equals 2. So we're using the common difference principle to set two equations equal so we can solve for one variable. It's a trick of solving for one variable when you have two variables that exist. If you can set the equations equal to the same variable, then you can essentially eliminate it by setting the equations equal to each other. So that's arithmetic sequence. Bonus short. Best of luck with this. This is bonus for grade 10, but definitely going to come in handy later. If you want to challenge yourself, get after it. Thanks.